Hi everyone, we are going to do a quick video today on what is called the triangle inequality theorem. And to start, we're just going to define that. So if you need to, pause, write this down on your notes, the definition of the triangle inequality theorem. And all that it is that in any triangle, the sum of any two sides must be bigger than the third side. So take a second and write that down. I'm going to highlight kind of the key word there, the sum of any two sides. So that means that in any triangle, I can pick two of the sides and add them up, and they must be bigger than the third side. So I'm just going to write like a quick example down here. Okay, so I'm going to make up a random triangle. This is not drawn to scale. Let's say this is 4, and this is 9, and this is, 6. The triangle inequality says, hey, if I pick any two sides, so let's say I pick sides 4 and 9, if I add them up, 4 plus 9 must be bigger than the remaining side, which is 6. And this is true. Look, 4 plus 9, that's 13, is greater than 6, check. And you could do this with any side. So I could pick another side. I could pick 6 and 9 and add them up. 6 plus 9 must be bigger than the third side. So I chose 6 and 9. The third side would be 4. Add those up. 6 plus 9, that's 15, must be bigger than 4. That works. And again, let's just do it with the third side just to make sure, or the third set. So the only two I haven't picked is 4 and 6. So if I pick 4 and 6, I do 4 plus 6 and add them up. They should be bigger than the third side, which is 9. 4 plus 6 is 10. That's bigger than 9. That works. So the triangle inequality theorem is as simple as that. It's just that if you pick any two sides of the triangle and add them up, they must be bigger than the third side. Now let's look at what an example of this is going to look like in geometry, because usually in geometry I'm not going to give you one with all the numbers. We're going to use x's. We might have to solve an equation. You guys are used to that by now. So this is a standard example of what this will look like. Is I'm going to give you a triangle, and I'm going to label two of the sides. Let's say this is 5, and the other one is 12, and this is x. Alright, so in this example problem, what you would be asked to do is find the restrictions on x. Restrictions just means what are the limits? What are all of the numbers that x can possibly be to make this triangle meet the triangle inequality theorem? So to do that, what we do is kind of like we just did, is we set up all of these scenarios. So one scenario is, here are the two sides, 5 and 12. We would add them up, 5 plus 12, and we know that they must be bigger than the third side, which is x. So that's one scenario. All right, what's another scenario? Pick another different two sides. So the other next set of two sides I'm going to pick is 5 and x. Okay, so if I add 5 and x, they must be bigger than the third side, which is 12. All right. And let's do the third set. So there's only one more set. What would that be? I haven't done x and 12. So x and 12. And x and 12, I would do x plus 12, add them. They must be bigger than the side I'm not using, which is 5. Now, these inequalities, we solve them just like equations. They're very straightforward. So let's go to this first inequality and figure out what the restrictions are. My like terms are on one side, so I'm just going to add 5 and 12. 5 and 12 is 17. 17 is greater than x. So we're done, actually. That's solved. Now, I'm going to rewrite this because I like putting the variable on the other side. So 17 is greater than x is the same as saying that x is less than 17. See how the pointy side of the inequality is pointing at the x? It's still pointing at the x. So this is one of my answers. X is greater than 17. The other one, I have to actually solve this. I want to solve for x, so I'm going to subtract 5 and subtract 5. And I get x is greater than 12 minus 5 is 7. And then the last one, I need to subtract 12 and subtract 12. And I get x is greater than 5 minus 12 is negative 7. Oh, let me make sure you can see that negative. So let's think about this one. So my restrictions on x is that x must be smaller than 17. And remember, x is a side length, right? X must be smaller than 17. It must be bigger than 7. And it also must be bigger than negative 7. Remember, we're talking about a side length. So sides cannot be negative, right? So they can't be negative. So I'm just going to cross this one out. We don't really care about that one. These are our two restrictions that really matter. X must be less than 17 and greater than 7. So to write this, I'm just going to put x in the middle. I'm going to put the biggest restriction, 17, on one side. X must be smaller than 17. And the other restriction, x must be greater than 7, on the other side. Really, what you can say is x must be between 7 and 17. We're going to move on in a second, but we are going to talk about, just really quickly, this inequality. Sometimes this is confusing, just the way that this is written. Just remember, we put x in the middle, and like the smaller number is on the left, the bigger number is on the 17, or the bigger number is on the right. It just means that x is in between 7 and 17. All right, now you guys will be happy to hear that there is an easier way to do this. Look at your original three numbers, 5, 12, and then this mystery number x. Now look at our number right here, 17. The biggest number x can be 17. Forget all of this math. The biggest number that x can be is just adding these two together. 5 and 12 gives you 17. Now look at the smaller number, 7. The smallest number that x can be, look back at your original problem, 5 and 12. To get that number, all we do is subtract these 12 and 5. So there is a little shortcut that we'll talk about in the next problem. All right, so let's do a quick example. In this quick example, I'm just going to show you how to use that little shortcut we talked about. All right, so here I have three sides. One of them is 9, one of them is 5, one of them is x. If I had to list the restrictions on x, I'm just going to use the shortcut here. So x has to be between two numbers. The biggest number that it can possibly be is, let's see here, 9 and 5 added together. So the biggest number it can be is 14. The smallest number that it can be is 9 and 5 subtracted. 9 minus 5 is 4. And so then we just create an inequality out of this. So x has to be bigger than 4 and smaller than 14. And that's our inequality. And you can write it like this: x must be between 4 and 14. All right, so there's going to be one for you to try. I want you to list the restrictions on x. And here's your triangle. So Mr. Ortiz is screaming next door. And let's say this would be 20, and this would be, I don't know, 8, and this would be x. So I want you to list the restrictions on x for this last example. Good luck.